For centuries, we gazed at the moon, thinking it was a barren, lifeless rock, a silent observer in the sky. But now, the very secrets lying beneath its dusty surface have shaken the world of science and may change humanity's future forever. What lies hidden inside these massive lunar tunnels, ancient craters or pathways to revolutionary discoveries? It all began with Japan's groundbreaking chang'e probe. While mapping the moon's surface, it detected over 200 mysterious dark shafts. But these aren't ordinary craters, they are entrances to vast underground networks called lava tubes, created billions of years ago by ancient volcanic activity. These lava tubes span hundreds of meters in width and plunge deep into the lunar crust. Preserved by the moon's lack of atmosphere and low gravity, they offer a glimpse into a world untouched for billions of years. Scientists speculate that within these tunnels could lie preserved geological treasures, ancient volcanic remnants, untapped mineral deposits, and perhaps even frozen water reservoirs. But the most exciting thought? These underground chambers might hold the key to human colonization. Unlike the moon's surface, which faces extreme radiation, meteoroid impacts, and fluctuating temperatures ranging from 250 degrees Fahrenheit to -280 degrees Fahrenheit, these tunnels are naturally shielded. They could one day become humanity's safe havens, protecting future astronauts or settlers from the harsh environment. Imagine inflatable habitats nestled inside these tubes, biodomes growing fresh produce, and advanced 3D printing transforming lunar soil into solid, sustainable walls. These innovations are no longer science fiction, they are the foundation of humanity's next giant leap. Before we venture inside, our robotic pioneers are paving the way. Meet Space Hopper, a nimble explorer designed to hop across uneven terrain, equipped with AI to scan and map these ancient corridors. Joining it are advanced rovers like NASA's DU Axle, which splits into two units to explore tight spaces, and Deus Mapper, a marvel of 3D imaging. These robots don't just explore, they survive. With temperatures plummeting to -280 degrees Fahrenheit and no atmosphere to shield them, they represent humanity's resilience in the face of extraterrestrial extremes. Beneath the moon's shadowy craters lies one of the most valuable resources for space exploration: water ice. It can be converted into drinking water, breathable oxygen, and even rocket fuel. This discovery has turned the moon into a launchpad for deeper space missions. Then there's helium-3, a rare isotope that could revolutionize energy on Earth. Clean, limitless, and capable of powering nuclear fusion, its reserves on the moon are worth trillions of dollars. The race to mine helium-3 could change not just space exploration, but the future of energy on Earth. But with great potential comes great controversy. Who owns the moon? As nations and private companies eye lunar resources, the risk of conflict grows. Could the moon's riches lead to a new era of inequality or even space wars? The 1967 Outer Space Treaty prohibits national sovereignty in space, but it's unclear how this applies to private companies. This legal gray area could ignite fierce debates, and possibly conflicts, in the years to come. Despite the challenges, the moon remains our best stepping stone to the stars. Lava tubes could host research stations, mining operations, and even launch platforms for missions to Mars and beyond. Mastering life on the moon will teach us how to survive in hostile environments, unlocking the potential for humanity to become a multi-planetary species. Yet, as we look to the moon, we must ask ourselves, what dangers lurk within these uncharted tunnels? Could there be unstable structures, hidden gases, or even microbial life forms that challenge our understanding of biology? The moon's secrets are no longer out of reach. As we prepare to uncover its ancient depths, we are not just exploring a celestial neighbor, we're embarking on a journey that could redefine humanity's place in the universe. Will the moon be our gateway to the stars or a battleground for resources? The choice is ours. What do you think lies beneath the moon's surface? Join the conversation in the comments below and subscribe for more cosmic discoveries. The moon has always been a beacon of wonder and mystery for humanity. For millennia, it served as a cultural and scientific touchstone, inspiring myths, guiding calendars, and sparking our earliest aspirations for space exploration. Yet, with all the advances made in lunar science, one discovery has stunned even the most seasoned researchers: massive underground lava tubes that could hold secrets to the Moon's past and humanity's future. The Moon's surface has been studied extensively since the era of Apollo missions, which began in 1969 and captivated the world with humanity's first footsteps on an extraterrestrial body. However, beneath the Moon's dusty and cratered surface lies a hidden realm of untapped potential, largely invisible to earlier generations of explorers. Advanced imaging technology has now uncovered these subterranean structures, revealing an underground landscape that promises to redefine our understanding of our celestial neighbor. Let's explore how this groundbreaking discovery reshapes our vision for space exploration, fuels geopolitical intrigue, and even forces us to confront philosophical questions about our place in the universe. The story of the Moon begins billions of years ago, in a chaotic early solar system. Massive collisions between protoplanets and planetesimals formed our Earth and Moon, leaving both bodies geologically active in their youth. Lava tubes, the key players in this narrative, were created during this period of intense volcanic activity. When molten lava flowed across the Moon's surface, the top layers cooled and solidified while the lava beneath continued to flow, eventually draining away and leaving behind hollow channels. These lava tubes became massive underground networks, preserved in near-pristine condition due to the Moon's lack of atmosphere and low gravity. Unlike Earth, where similar formations collapse under tectonic activity or erosion, the Moon's lava tubes have survived for billions of years, providing an untouched time capsule of the Moon's volcanic history. The discovery of these ancient tunnels has been a gradual process. While scientists hypothesized their existence as early as the Apollo era, it wasn't until modern space probes like Japan's Kaguya and NASA's Lunar Reconnaissance Orbiter, LRO, mapped the Moon in unprecedented detail that these formations were confirmed. Detecting lava tubes beneath the Moon's surface required advanced imaging techniques and ground-penetrating radar systems. High-resolution cameras on board spacecraft captured images of skylights, vertical shafts that provide entry points into these tunnels. The LRO's radar mapping revealed the extent of these underground networks, some stretching for kilometers and large enough to fit entire cities. Space agencies around the globe, including NASA, the European Space Agency, ESA, and China's CNSA, are now turning their focus to these subterranean structures. Probes like the upcoming Lunar Surface Asset Testbed, LSAT, will carry cutting-edge radar systems capable of probing even deeper into the Moon's crust, uncovering more hidden tunnels and their potential resources. Lava tubes are more than mere geological curiosities, they represent a scientific goldmine. These tunnels are shielded from the Moon's harsh surface environment, which includes extreme temperature fluctuations, constant bombardment by micrometeoroids, and unfiltered cosmic radiation. As such, they preserve invaluable geological data, potentially including remnants of ancient water ice, minerals, and even clues about the Moon's formation. Understanding the Moon's volcanic history is crucial for piecing together the larger puzzle of planetary evolution in the solar system. Studying the composition of rock samples from these tunnels could reveal insights into the conditions that shaped not only the Moon but also Earth. Perhaps the most exciting prospect of lava tubes is their potential to support human habitation. Establishing a permanent presence on the Moon is one of humanity's loftiest ambitions, yet the challenges are daunting. Radiation exposure is a significant risk for astronauts on the Moon's surface, where the lack of an atmosphere leaves them vulnerable to solar and cosmic radiation. Temperatures can swing from 127 degrees Celsius, 260 degrees Fahrenheit, in the daytime to minus 173 degrees Celsius, minus 280 degrees Fahrenheit, at night. Lava tubes offer natural protection from these hazards, providing a stable and insulated environment for building habitats. Engineers and architects are already designing concepts for lunar colonies within these tunnels. Inflatable modules could be deployed inside lava tubes to create living spaces, while 3D printing technology could construct walls and infrastructure using lunar regolith. This reduces the dependency on costly Earth-launched materials, making lunar habitation more feasible. Lava tubes could also hold the key to solving one of space exploration's most pressing problems: resources. Water ice, which has already been detected in permanently shadowed craters near the lunar poles, could also exist within lava tubes. This ice can be converted into drinking water, oxygen for breathing, and hydrogen for rocket fuel, making it an essential resource for long-term missions. But the Moon's most tantalizing resource is helium-3, a rare isotope believed to be abundant on its surface. Helium-3 could revolutionize energy production on Earth, serving as fuel for nuclear fusion reactors that produce no radioactive waste. Estimates suggest that the Moon holds enough helium-3 to power Earth for thousands of years. However, extracting these resources presents ethical and legal dilemmas. Who owns the Moon's resources? The 1967 Outer Space Treaty declares the Moon the province of all mankind, but it offers little guidance on how its resources should be shared. As nations and private companies race to exploit lunar wealth, these questions will become increasingly urgent. The discovery of lava tubes has intensified the global competition for lunar dominance. Countries like the United States, China, India, and Russia, as well as private companies like SpaceX and Blue Origin, are vying to lead the next era of lunar exploration. China's chang'e missions have already made significant strides, including landing on the Moon's far side and deploying a rover to explore its surface. The US Artemis program aims to return humans to the Moon by the late 2020s, with a focus on establishing a sustainable presence. Both nations have expressed interest in studying lava tubes as potential habitats and resource hubs. To unlock the secrets of lava tubes, robotic explorers are paving the way. NASA's DU Axel rover, equipped with a dual-part system, can detach to navigate narrow tunnels. The Deus mapper uses advanced sensors to create 3D maps of underground environments. Drones and crawlers equipped with AI are also being developed to venture into these hazardous regions, collecting data and samples without risking human lives. These machines are essential for overcoming the challenges of navigating the Moon's unpredictable terrain. The race to exploit lunar resources raises profound ethical questions. Who should benefit from the Moon's wealth? How do we prevent conflicts over its resources? Some experts argue that space exploration must prioritize international cooperation and sustainability. Initiatives like the Artemis Accords aim to establish guidelines for responsible exploration, but not all nations have signed on. The Moon could become a test case for humanity's ability to share resources equitably on a global scale. The Moon's lava tubes could serve as a crucial stepping stone for deeper space exploration. By mastering the challenges of living and working on the Moon, humanity can gain the experience needed for missions to Mars and beyond. The Moon's proximity to Earth makes it an ideal training ground for testing life support systems, resource extraction technologies, and psychological resilience in extreme environments. It could also become a launchpad for missions, with its lower gravity making it easier to send spacecraft to other destinations in the solar system. Beyond the practical benefits, the discovery of lava tubes forces us to confront deeper questions about our place in the cosmos. What does it mean to extend human civilization beyond Earth? Can we learn from our mistakes on Earth and create a more equitable and sustainable future in space? The Moon's hidden tunnels are a reminder of the vast mysteries that still await us, both within our solar system and beyond. Each step forward in exploration brings us closer to answering the age-old question, are we alone in the universe?